Section 5, we're going to look at what's called symmetry. We can use symmetry in terms of two-dimensional and three-dimensional figures, which is what we're going to do. So we're going to look at specific types, one being line symmetry and the other one being rotational symmetry in terms of two-dimensional figures, and then we'll look at plane and axis symmetries in three-dimensional figures. So first part that we're going to look at is what is line symmetry. There's a ton, a ton of vocabulary in this section that you'll want to get down. Basically, line symmetry looks like this shape in this box. Notice when I draw the line right down the middle, if I was to fold over this half over top of this line, it would fold directly on top of the other half. Think of almost taking a sheet of paper and folding it straight in half. That line that you folded it on would be considered the line of symmetry. Okay, that's really what we're after. So looking at these over here, your job is to figure out how many lines of symmetry can I draw on each shape. So we're going to look at 1B first and C, and then we'll come back to letter A. B has one line of symmetry, and it would be the one that goes straight down the top. Notice I missed it a little bit, but it would go directly over the top of it. 1C is going to have two lines of symmetry going in this direction. If I could draw it straight down the middle, that would be awesome. And this direction as well. My lines are not anywhere near the middle. Try and slide it over a little bit. There you go. Looks maybe just a little bit better. Try and do this with this one. But notice when I try and draw in those lines of symmetry, they are going to be directly in the center, and if I would fold them over, they would fold right on top of each other. 1A is kind of interesting, where you think that there might be a couple lines of symmetry, but there aren't any at all. So I'm going to show you one direction, and the other direction will work pretty similar. Some people might think that, yeah, drawing in a line like that would actually get me a line of symmetry. But that's not true. If I take this point up here at the top by 1A, right here, and I was to draw its new point after I reflect it, remember it's got to cross at a 90-degree angle. That looks to be about 90 degrees down there, going the same distance. Notice how it doesn't end up on this spot right here. So we would say that it does not have a line of symmetry on it. So this one's going to have none. This one will have one, and this one will have two. And that's all there is to it for line symmetry. The next type of two-dimensional symmetry is what we're calling rotational symmetry. Rotational symmetry, it sounds just like what it is. You're trying to rotate a shape so that it lines back up with its original. We're going to have what we call order and magnitude of symmetry. Order is the number of times that you can spin your shape, and your magnitude is taking 360 divided by the order. That will get you the one angle measure between each spin. So we're going to look at a couple problems that deal with rotational symmetry. Looking at letter A. Letter A does have rotational symmetry, so I'm just going to write yes. Then I need to come up with the order and the magnitude. The order is going to be how many times I can spin it. So this one really has the same number. The order is the same as the number of points on this thing. So it looks like 1, 2, 3, 4, 5, 6. Order is going to be 6. To find the magnitude, we take our order over 360 divided by our order, and that will get us 60 degrees. Okay, so that's how you would do it. Letter B, there is none. The only time that would get me there is if I went all the way back around, and if I have to do that, then there is no order and there's no rotational symmetry at all. Letter C, this one is yes, maybe a little bit harder to see. The order, though, is going to be 2, and the magnitude then would be 360 divided by 2, which is 180 degrees. So that would be rotational symmetry. Now we're going to start looking at three-dimensional symmetry. So we have plane symmetry and we have axis symmetry. Plane symmetry is very similar to line symmetry in two-dimensional. So if I draw in a line, would it cut my shape directly in half? It'd be the same on each side, just kind of like this picture is showing right here. Axis of symmetry, it's pretty much the same thing as rotational symmetry. Can I spin it so it looks exactly the same? Looking at a few examples, letter A in here, we would say that this one has plane symmetry because I can cut straight up from the top. And if I cut directly along that line, right through the top of it, then I would cut it into two equal halves. And I can't spin it because it will never look like that again. Letter B, we would say that this one has both. I can cut from the top, or excuse me, I can cut straight through the middle, right in through here. So that way it's exactly the same on both sides. And then I can also spin it from the top. So we would say that this has both plane and axis symmetry. And that's really all there is to symmetry.